Woodman here. It is Sunday, August 11th, 2024. I hope you are having a wonderful day. May the Almighty God bring you peace, blessings, and protection and watch over your life as we continue to honor the Most High God, have faith in Him, His Son, Jesus Christ, the Messiah, Mother Sophia of Wisdom, and the Holy Spirit of the universe. I wanted to talk to you today about numeral systems and how it affects the world around us. So let's start with base 2. This is the binary system, which has the digits 0 and 1 on and off. This is what most machines and computers are based off of. The binary system uses only the two digits 0 and 1. This is because in base 2, each digit represents a power of 2. So, for example, in binary, the number 101 represents 1 times 10 2 to the second power, 0 times 2 to the first power, and 1 times 2 to the 0th power, which equals 5 in decimal notation. Apologize for any mistakes there. In base 5, which is the quinary system, we have 5 digits, 0, 1, 2, 3, 4. The base 5 system uses digits ranging from 0 to 4. Each digit represents a power of 5. So for instance, the number 243 in base 5 is computed as 2 times 5 to the second power plus 4 times 5 to the first power and 3 times 5 to the 0th power, which equals 73 in decimal notation. Now we reach base 10, which is the decimal system. This is the system we rely on every day. So we have the digits 0 through 9, and the explanation is that the decimal system, which is base 10, uses 10 digits ranging from 0 to 9. Each digit represents a power of 10. So for example, the number 345 in base 10 is computed as 3 times 10 to the second power plus 4 times 10 to the first power plus 5 times 10 to the 0th power, which equals 345 in decimal notation. Then we get to base 16, which is the hexadecimal system. This has digits from 0 through 9, and then letters from A through F, where A is 10 and F is 15. In terms of the explanation, the hexadecimal system, which is our decimal plus a hex, right, hex being 6, extends beyond the decimal system with an additional set of digits represented by letters. Digits 0 to 9 represent the values 0 to 9, and A through F represent values 10 through 15. So for instance, in hexadecimal, the number 1A3 is computed as 1 times 16 to the second power plus 10 times 16 to the first power plus 3 times 16 to the 0th power, which equals 419 in decimal notation. So in this very real sense, these numbers are actually very important because many societies that have developed over the course of human history relied on these types of systems in order to bring order to things. And when you think about that, that's almost like a divine development, because the logic and the thought which went into these societies developing these number systems is almost magical, right? Think of the concept of zero and number systems, how it has evolved over time in human history. Ancient societies had various methods for representing numbers, and the introduction and use of zero played a crucial role in the development of modern mathematics. Here's a look at how some ancient societies represented the numbers in their societies, including the number zero. So, for example, in ancient Mesopotamia, their numeral system was base 60, which is the sexagesimal system. And from a mathematical standpoint, 60 is a great number because if we have a circle with 360 degrees, then it's easy to see how we develop clock systems and anything based off of circles, which is easy to compute based on using base 60. The Mesopotamians really loved this system. They had symbols for 1 and 10, which they combined to represent larger numbers. So, for instance, 1 was represented by a small vertical wedge, and 10 was represented by a corner wedge. The 0 in Mesopotamian numerals did not have a true 0 symbol initially. However, one did develop in time. Around 300 BCE, they began using a placeholder symbol, which is kind of like a space or a special symbol to indicate the absence of a number in a given place, similar to how 0 functions in positional numeral systems. This placeholder was not a full-fledged 0, but it helped in distinguishing different magnitudes. And if you think about that, that's what distinguishes a rational system from an interval system, right? Because in an interval system, 0 doesn't necessarily mean true 0. But in a rational system, it does, right? In a rational being, it can be expressed as a fraction, and fractions can be converted to decimals. Let's talk about the ancient Egyptians. So their numeral system was actually base 10. They used a decimal system. So their representation was that they used a base 10 system represented by different hieroglyphs for units, ones, tens, hundreds, thousands, and so forth. They used these hieroglyphs in combination to represent numbers. In terms of zero, ancient Egyptian numerals did not have a symbol for zero. They used a system of additive notation, meaning that there was no need for a zero to indicate a place value as their system was not positional, which is kind of interesting in and of itself, right? Because we use that entirely positional decimal system, but obviously Egyptians had a different way of thinking about things. Let's look at the ancient Greeks. So their numeral system was base 10 also. And if you think about it in terms of representation, they used a numeral system based on the letters of their alphabet. So, for example, alpha would stand for 1, beta stands for 2, all the way up to 9, and then using a combination of letters to represent tens and hundreds. In terms of zero, like the Egyptians, the Greeks did not have a symbol for zero. Their system was additive and did not require a zero to indicate place value. So as you can see, this is kind of very similar to what went on with the Greeks and the Egyptians, but and the Romans, who would also base their society partially on the way the Greeks did things, would adopt something similar, right? Their numeral system was base 10. It was a decimal system. Their representation used combinations of letters from the Latin alphabet, I being 1, V being 5, X being 10, L being 50, C being 100, D being 500, and M being 1,000. Roman numerals are additive, but also subtractive in certain cases. For example, IV being subtract an I from the V to give us the number 4. In terms of zero, they did not include a zero. Their numeral system was primarily used for counting and recording, which is very similar to being additive and subtractive and is thus not positional. What about ancient India? Well, in terms of their numeral system, they also had a base 10 system, a decimal system, and they had a constant of zero. Surprise, surprise. One of the few societies that did develop this, right? So, in their representation, ancient Indian mathematicians developed a sophisticated base 10 numeral system for which they included a symbol for zero. This system was fully positional, and the concept of zero was integral. The symbol for zero, which was known in the word shunya, allowed for the clear representation of numbers and calculations. There's zero in the Indian numeral system, which was later transmitted to the Islamic world in Europe, included a dot or small circle to represent zero. This innovation was crucial for advancing mathematics as it enabled the development of algebra and more complex arithmetic operations. So when you think about it, when we keep saying, oh, we're using Arabic numerals, what we're really using are Arabic numerals that were supplemented by the Indian numerals. In other words, it was a combination of both cultures. Let's go to ancient China. In ancient China, their numeral system was base 10, and it was a decimal system, but they used counting rods. So their representation, the Chinese used a rod numeral system where different rods represented units, tens, hundreds, and so forth. They also used a base 10 system in their written records. In terms of a zero, the early Chinese numeral systems did not have a symbol for zero. However, by the Tang Dynasty, which is 618 to 907 CE, Chinese mathematicians used a placeholder in their counting rod system to indicate an empty place value similar to the concept of zero. And of course, Chinese being on the Asian continent, it's not hard or stretched to believe that eventually they might have come in contact with other Asian systems which would have included a zero, like the Indians. So let's summarize. In Mesopotamia, they used a base 60 system with a placeholder, not a true zero. In Egypt, they used a base 10 system without a zero. In Greece, they used a base 10 system but without a zero. In Rome, they used a base 10 system without a zero. In India, they used a base 10 system with a specific symbol for zero. In China, they used a base 10 system with a placeholder concept for zero. And so when you think about how this occurred over time, this is almost very divinely inspired, which shows you that there is something else going on in our world which is quite special. The development and adoption of zero as a numerical concept and its incorporation into positional numeral systems was a pivotal advancement in mathematics, and that facilitated more complex calculations and inevitably led to the development of algebra as a whole, which really, from there, allowed us to go into other things like calculus and so forth, other advanced mathematical topics. The idea is that numbers are a divine reflection of God, and the concept of retrocausality are profound and intriguing concepts that really touch upon mathematics, philosophy, and metaphysics. Let's go into a further explanation of these ideas and why they would in fact matter. So let's talk first about numbers as a divine reflection. From a mathematical concept, we have Platonism and the divine. And in mathematical Platonism, this philosophical viewpoint posits that mathematical entities, such as numbers, shapes, functions, exist independently of human thought. In other words, where do thoughts come from? Are they something that we generate solely in our brains, or are they perhaps divinely inspired from other places and other worlds and other universes? According to the Platonists, these abstract objects are timeless and they are discoverable rather than truly invented out of thin air. As terms of divine reflection, in the context of Platonism, numbers and mathematical structures might be seen as a reflection of a higher order or divine reality. For example, the ancient Greek philosopher Pythagoras and his followers believed that numbers and mathematical relationships underlie the order of the cosmos and that they reflect a divine harmony, such that, yes, human beings came to understand it over time, but they were not the original inventors. Let's talk about the theological interpretations. So, in terms of divine order, many religious traditions view the universe as a reflection of a divine order. In this view, the precision and consistency of mathematical relationships are seen as evidence of a higher intelligence as well as a divine creator. For instance, in Christianity, the idea that God is the creator of an orderly universe would necessarily imply that mathematical principles are a manifestation of divine wisdom. All hail to God. In terms of symbolism, the numbers have often been imbued with spiritual significance. For example, the number 7 is considered sacred in many traditions, for example, in Christianity and Judaism, representing completeness or divine perfection. Sometimes the number 3 may take on this characteristic as well. And for other types of ethnic concepts or philosophies, 6 isn't necessarily such a terrible number, even though some view it as incomplete, but not in every culture. From a numerological standpoint, there's a belief that mystical significance to numbers and their influence on human affairs is an orderly part of the universe. Numerologists argue that numbers can have a divine essence that can reveal deeper truths about existence in the cosmos. For example, as I've been doing this particular video, a lot of angel numbers have popped up as I've looked away and looked back at different times. So many would interpret that as some sort of divine inspiration that whatever I'm doing, I'm on the right track. So therefore, we look at numbers as a means to understand the divine nature of the reality we exist in. Now, let's go into the idea of retrocausality, which I've discussed in previous videos, but I'll give a little refresher here, particularly if you haven't viewed any of those previous videos. The concept of retrocausality is that there's an idea that future events can influence past events. In other words, the future can have causal effects on the past, which contradicts our usual understanding of time, where cause precedes effect. As I told you, time is an illusion. If you can imagine the whole universe being mapped out with 3 dimensions representing physical objects and a 4th dimension representing the passage of time, then in quantum mechanics in that realm, retrocausality is explored in the context of phenomena like delayed choice experiment, where the outcome of a quantum measurement seems to be influenced by future choices made by an observer. In other words, we might think that past events are what caused the future, but if the future event is already determined, then the future is going to draw the past closer and closer to the outcome that the future holds. Time symmetry. Some interpretations of quantum mechanics suggest that time may be symmetric, meaning that physical laws are the same whether time moves forward or backward. This can lead to a theoretical possibility of retrocausality, because in fact, the exact point in time that we're looking at may not really matter. It may not necessarily be that it has to be a build-up from past going to future. It could be a build-up from future going back to the past. Retrocausality, however, challenges traditional notions of causality and free will, raising some questions about how future events could potentially affect past decisions and actions. So, if it's already decided that maybe, for example, I'm going to take a certain action, then is it really by free will, or is it just that the universe is conforming? Are we really people who decide our own destinies, or are we just actors in a play that's already been written out? The concept of an omniscient deity who knows the future would be interpreted to imply that future events are somehow already fixed and could influence events of the present or past. This could be seen as a form of retrocausality in a divine context. What about timelessness? Some religious and philosophical perspectives propose that divine beings exist outside of time. From this viewpoint, the divine might perceive all events simultaneously, making retrocausality a non issue in the divine realm, but a matter of our limited temporal experience. In other words, since we can only experience things as time passes, for us, we see things as linear. But truly, for the divine and greater beings, things may very well be nonlinear and don't have to conform to any particular direction or progression. What about divine mathematics? There is the idea that numbers are a divine reflection, which suggests that mathematical truths are eternal and they're unchanging and are just waiting to be discovered as opposed to being created out of thin air. So this mirrors a divine order or intelligence behind the universe. In this sense, the precision and consistency of mathematics can be seen as evidence of a higher divine structure, one which must conform to rules which have already been put into play. Let's talk about retrocausality and divine knowledge. If one considers that a divine being possesses complete knowledge of all time, the concept of retrocausality might be framed as a manifestation of divine omniscience. In this way, the divine perspective encompasses all events, including potential influences of the future on the past. If you ever watched a DC Comics show known as Watchmen, then you would have seen this in the story arc of Dr. Manhattan, which is that Dr. Manhattan already knew things that were going to happen long before they happened, and that he basically saw himself as being helpless because since certain things were already set into motion that were going to take place, he had no true power to really change the events. He could see them, and that did make him like a godlike being, but he didn't have an ability to deviate from what already was, which made him not so godlike. In summary, viewing numbers as a divine reflection integrates mathematical concepts with theological interpretations, and this suggests that the structure and order of mathematics can reveal a lot about the aspects of our divine reality. Retrocausality, on the other hand, challenges traditional notions of time and causality, that time isn't necessarily linear, and that it can be explored within both science and metaphysical frameworks. I hope you've enjoyed this message. If you're new here, welcome aboard. It's a safe space. You're welcome. If you are returning, thank you, family. I appreciate you. You make this channel great. In the name of the Most High God and the Messiah, Jesus Christ, the Mother of Wisdom, Sophia, as well as the Holy Spirit of the universe, I continue to wish you divine blessings, protection, and the very best as you try to fulfill your life purpose. I wish you well. Woodman signing off. Take care.